The fourth exercise in manufacturing technology 2 practical is knurling and thread cutting. In this exercise, let's part model these features, knurling and threading, because these two are advanced features in solid modeling using PTC Creo. Okay, this is an input sketch given for our practical lab workshop. We have to use the dimension here, knurling features and chamfer, and this is BSW right hand side 3/4 inch thread size. Usually the BSW standard is called other way around Whitworth. Whitworth standard dimension is given here. We are going to create a pitch value of 1.5. Then every radius should be as per this guideline. For example, this radius should be 0.1373 times the pitch value, and this overall height should be 0.9605 times P. Okay, now we are going to create the fourth exercise in manufacturing technology 2 practicals part modeling. For that, let's start with the new part, and this one regarding knurling and threading. Okay, this fourth exercise is for that. Okay, taken already one more trial. Okay, in this let us choose this, or let's choose this solid part mmks. Okay, and in this exercise also we are going to start with revolve surface, revolve solid, solid revolve, and in the front plane we are going to create the outer profile of the revolve solid. And let's view the sketch plane and start with as usual 2 lines and control. Since it's revolve, let us follow the same step. First let us create the center line. Okay, after that let's start with 2 lines. Okay, first dia is 23 mm as per the input, and this distance is now, let's see the sketch, 15 mm. Okay, let's see, let's keep it 15 mm. Okay, and then draw a line. Okay, down, and then not that green signal shows equal length. We should not match with any of that green signal, otherwise we cannot control dimensions. Okay, this is our basic layout. Now we have to control the dimensions one by one. Okay, what is this dia? This one, let's see it in the sketch. This dia is 1 mm, 1 mm. Okay, it should be 25, 15. Okay, this one 23, 10. Okay, let's control this. 23, 10, then 25, 15. Okay, these two done. Okay, what else? Then 5 mm, This one is 5 mm. Okay, that dia is 16 dia. Okay, 16 dia. Okay, and then this one, this dia should be 3/4 of 1 inch. So 3/4 times 3/4 times, otherwise let's go this way around. 25.4 times, because we have taken the metric unit template. That's why we have to multiply that 3/4 inch, 3/4 of 1 inch by 25.4 mm. Okay, then this one given 24. This is what our 3/4 inch BSW inch thread equivalent in mm. Okay, everything strong, everything looks fine. That's it. Let's revolve it. Okay, in this exercise they are given chamfer in 4 places with angle and distance. Angle 45 degrees and distance 1 mm. Okay, let's choose this edge and then this edge, this edge and this edge. Okay, now everything done. Now part modeling is half done. Now the next step is we have to create the knurling using the part modeling advanced feature commands. Let's take the helical sweep and let's create the helix profile. And for that let's choose the front plane. Okay, instead of taking the right datum plane, let's choose the surface. Okay, let's sketch it. Let's view the sketch view and draw a center line first. Okay, now I need 2 more references so that it will give me clear idea for dimensioning and controlling and constraining the sketch. Let's check. Yeah, this is fully placed. Now I'm going to create a line. Okay, for helix profile from somewhere away from these 2 edges. Let's see, let's keep it 18 somewhat. And this one, let's keep it 2 mm. Okay, now we have created the helix profile. Okay, now we need to create a section. That section sketch, let's create it. Let's create that section sketch here, a small triangle. Okay, and this triangle, since it's going to become a knurling, let's control its height to very minimum. Maybe 0.2 is more than sufficient. And this angle, let's keep it 60. And again let's keep this angle also to become 60. Okay, it seems this drawing is fully constrained. Let's try taking that material out. Everything fine. Okay, that's going to take the material out. Remove the material it's taking. Let's keep that 18 mm full length. Let's take 20 mm. Okay, still let's take 30 then, whether it covers half of that. Yes, almost half of that. Skip S10, 18 as it is. Okay, we need for only 13. Okay, so that it will become nice helix. Okay, let's keep it as it is to become 30. Then let's play with this value again. Okay, let's create one more helix. Helical sweep. Okay, now helix profile in the front plane, and instead of the right datum, let's select this face and sketch it. Okay, and first thing, let's create a center line. Okay, and then let's add two more references to control the sketch in place. Okay, okay, it's fully placed. Let's draw that helix profile line as usual, something about 18 mm, 18 mm, and this let's keep it 2 mm away from that. Let's take it up and create that helix section curve. That is a small triangle at this place. Small triangle at this place. First, let's control this angle to 60, and this distance 0.2 is sufficient. Let's give another triangle so that it will become another angle so that it will become equilateral. Everything looks fine. Okay, let's go out, and this time let's remove the material and give that same 30 pitch but left-handed. Okay, it's happened as it is expected. Yes. Now the another step is using first helix. Let's create a pattern about the axis so that it will become circular pattern, and give it, let's maintain 12, 360 by 12. Okay, let's see it, it's happening. And another pattern, since it's circular, let's take axis. This one is reference axis, gives us 12 mm, and 360 divided by 12, it's coming 30, right? Okay, this is our knurling, but I can add more closer distance, but my system will hang. Okay, this is just to show the symbolic meaning of knurling. Okay, the next stuff is we have to create a thread. Here a thread is BSW. The BSW is usually called Whitworth thread. Again, the helical sweep for threading. First, let's create the helix profile using front plane, and instead of this, let's take the topmost surface. Okay, Let's start sketching it. View the sketch view. First, let's start with the center line. Okay, I may need two more references. Okay, let's select this as well as this edge. Okay, check it, close it. Okay, again sketch view. Now we have to create a line for helix profile, right? So let's start somewhere away from this. This is how. Let's keep it 50. Then this one, let's keep it 2.5. Okay, let's add helix profile. Done. Okay, close it. Now we have to go for the section. Okay, in this section we are going to create a BSW thread 3/4 of an inch with 1.5 pitch. Okay, let's create again once again the triangle. Okay, here the mandatory first thing and BSW thread is 55 angle, and the rest of the angle is equally distributed, right? Then let's assign like it. This one should be not 56. Let's do the calculation, simple calculation. Yeah, that is the beauty of parametric software like PTC Creo. Let's do this mathematical calculation, it will take it automatically. Here also it will become same. Okay, this should be P, right? Let's do 1.5. Okay, it looks nice, right? Then we have to give the radiuses at this distance. Whether it works or not, I don't know. It will work. Let's see. From this to this, it's exactly as per the BSW thread 1.44. We don't know how to edit it. The next step is let's try to give the fillet, because it will become a problem there. We give it. Okay, the fillet radius as per the BSW thread system is 0.1373 times the pitch 1.5. Okay, let's keep everything as it is. Okay, and this also I'm going to remove it. Now my pitch value is 1.5. This is what a BSW 3/4 of an inch thread. Okay, this is okay. If we try to control this sharp corner with a round command in this, it may hang, but let's see its value also, because it's processing a lot of data, right? Its value also 0.1373 times P. P is 1.5. Okay, it works, I think. That's it. We have created the thread system called BSW threading using PTC Creo. Thank you for watching this video.